that's quite an intro. That is better than my lousy GIF I have here. But yeah, servus. I'm Sebastian. I do work for Deutsche Telekom, but that actually doesn't really matter in this talk. I've done quite a bit of development in the past 13, 14 years, and half of it, nearly half of it, was IoT related. And for the past 5.5 years, I've been working on a smart home system for Deutsche Telekom, actually. But first, I'm AskiDisco on Twitter and GitHub. If you have any questions or want to meet after the talk, just use Twitter. Or if you don't use Twitter, there's an email account which says question@askidisco.com, where you can mail me questions if you're not into social media. So yeah, as I said, I've been working for Deutsche Telekom, and we have a white label solution platform called KiwiCon. In Austria, we have a reseller, EWW. I'm actually not really familiar with it, but this is the company in Austria which resells our solution. We have telcos and energy providers, etc., all over Europe reselling this. But yeah, as said, that really doesn't matter. Last shameless self-plug before we actually get to the meat. A couple of friends and I, we do run a local community conference in Cologne, which is where I'm from, which is called Nightly Build.io. Call for papers is still in progress, so if you have ideas about the future of work, front-end development, etc., well, please send them in. We're happy to receive as many proposals as we can, and we take good care of any speaker that has been chosen. So, enough shameless self-plugs. On to history lessons. So I did take a vacation and a conference tour in Seattle last year. So the interesting thing, aside from all the tech conferences, etc., to me was the history of Seattle, and actually the huge failure that the history of Seattle actually is. Like, throughout the entire 19th century, it's just like one huge, big mistake. So this is Seattle in the early 19th century. You see, it's quite close to the coast, which is not actually the ocean. They call it sound. It's more like a fjord, I'd say. But yeah, the interesting thing, so most of the people in Seattle back then were in the logging business, lots of trees. Nowadays, no more trees, tall buildings. But back then, they were there for the logging business. And because it was so convenient with the coast and the sea, they built their houses basically right onto the shore. And also, they disposed all the litter into the water. So they actually built pipes to drain all the, stuff from the land directly into the ocean. The thing is, though, even if that is not really the ocean, it has tide. So when the tide was going out, everything was okay. So all the litter and all the stuff from the pipes, the human stuff, basically got washed away into the ocean. But the thing is, if the tide is going in, well, the water just shoots right through the pipes and back. Let's just say you were very privileged if you had your toilet on a throne. That was actually a sign of wealth back then. A little later on, the whole thing got more established, like proper city, etc. They still haven't got rid of the problem with all that litter. You see, that is a street. You see these wagons, which are basically stuck in the mud, which is not really mud, because that is also quite close to the shoreline. And what did the beautiful people of Seattle think, yeah, well, we're in the logging business. What do we have enough from sawdust? So yeah, they put sawdust on the streets. Maybe that'll help. Of course, it didn't help. It was more like chocolate pudding with cereal, but no cereal, and unfortunately, no chocolate pudding. The situation got worse and worse and worse until there was a big fire that nearly destroyed all of the city. 14 districts, I think 29 blocks, completely destroyed. I mean, Americans, houses made out of wood, big fire, everything gone. That actually is a picture of the business district, which was, well, not existent anymore. But the brave people of Seattle, they saw a chance in this. Together with their newly elected mayor, they were going, okay, we're going to rebuild the city like proper houses, like the Europeans do, stone, great. And what we also gonna have is proper streets made of tarmac and like a proper pipe system below the city that is above the sea line. And the mayor said, yeah, we made a plan, we figured it out, we can do it. And the people of Seattle were like, yeah, great, let's build it, how long will it take? And the mayor said, approximately 10 years to build up all the streets and everything. And the people of Seattle were like, 10 years, I don't know, we have businesses, we can't go out of business for 10 years, you know? And of course, they started rebuilding the city on their own. But the mayor said, well, you can rebuild your homes, but we the city, we own the streets. So what happened? After the people built their houses, the city actually started building the streets and the piping system. And they did build it up to 3 to 9 meters above the old streets. So if you had a house in Seattle back then, you basically would go out of your first floor or the ground floor, and you would stand directly in front of a huge 9-meter-high wall with a street on top. So if you wanted to visit your neighbor, you had to climb up a ladder, go across the street, and climb down a ladder. Yeah, this is an actual picture from Seattle Underground tour you can take. So there's like a whole 19th century city below the streets. The street and the sidewalk are actually there. It is really amazing. If you're down there, they built little ceiling lights into the sidewalks so that a bit of light comes in. But basically, this is not used anymore except for tourists exploring this. It's really the whole inner city, the whole business district of Seattle has this city on the ground. And what was back then the ground floor is now the cellar, and what has been the first or second floor is now the ground floor of the buildings. Just easier as that. Why am I telling you this? Not only because I think it's a really interesting story and I do like history, but as someone who works in the smart home space, and also other people think that we're kind of like close to that fire, metaphorically seen, in the smart home business. The thing is, we need to fire up the businesses that we have. We need to have products, we need to make money and sell it to our customers, or wannabe customers. But we can't really wait for 10 years until it actually technologically had reached a point where we would be satisfied with the system at all. Yes, we as engineers of that systems are very dissatisfied with the status quo at the moment. To illustrate that, this is this is a screenshot from one of Europe's most popular smart home systems. It's only been sold in Austria, Switzerland, and Germany from Homatic. But until very recently, it was actually the best-selling system. And this is still the UI that you have today to steer your smart home. Air quotes, smart home. That is FHEM, one of the most popular open source systems in Europe in the smart home space. It's based on Perl. I don't usually rant about programming languages, but every time one of my cats jumps on the keyboard and does its thing, I think it's actually valid Perl syntax. But yeah, I mean, this is, if you take a look at this, this is not user-friendly. This is highly technical. This is a user interface, the same as this one, which is there for technically skilled people. And this is a bit of a problem. And I think it also is based on the answer to that question. What do we as developers, product managers, designers who work more or less in that space, what do we think when I say IoT, Internet of Things, or smart home, or whatever? I think many of you think about this. Arduino, Raspberry Pi, Sonos speakers, NetAtmo, your Philips Hue, or whatever systems, some smart plugs, etc. We think about devices, we think about technologies, platforms, protocols, systems, whatever. The more interesting question, though, is what do we forget about? Mostly, we forget about the user, which is a true fact. I've been working in that space for quite some time. We're doing user-centric development, and still, we tackle things very technologically. As developers, this is kind of a natural thing. So we're building systems that actually fight with the user, like go against the user's needs. If you remember that 2 screenshots I've shown you, we built horrible user experiences for extremely complex technologies, and we basically transfer that technological complexity 101 to the users. This might be okay-ish for an experienced tech person, but it's not for the average user. If we take a step back and think about what technology actually is, it is something that should enable users. It should enable users to do things they weren't capable of doing before. It should make things that are hard become easy or completely vanish and blur into the background so that you don't have to think about them anymore. It should just simply make hard things unnoticeable in our everyday lives. And we're failing at that at the moment. We do. So we need to understand 2 very, very different things to tackle that problem of not understanding. We need to understand the user, and we need to understand the technology side of it. So as we're at a tech conference, I'm doing a quick what the protocol, smart home, let's say little thingy. So smart home protocols. Name a few. It's easy because there are many. If you know about the thing with the JavaScript front-end frameworks, and it's like, oh yeah, every day a new framework, it's basically the same here. It's like, oh yeah, every day a new protocol. Oh, there's a new Kickstarter from a startup. They don't use what's out there. They invent a new protocol, of course. It's like countless. You get new protocols really like every week or so. And of course, there's an XKCD for that, which just is so on point. The not invented here syndrome, I don't know. It's basically, it's just a shit show with smart home protocols. And what comes along with it is this problem, which is you have a gazillion apps on your phone to steer all of your different devices. It's like, oh yeah, great, I've got the Philips Hue lighting system and I can control them with that. But now I have actually a switch from, I don't know, Belkin or some other vendor. Great, I would like to turn on the light with that switch I just bought. Doesn't work. But yeah, you have two apps. One app that says you, oh, you pushed the switch. And one app, you can then go manually change the lighting scene. It's not the thing that we're in one locked ecosystem here or two. We're in many, many, many ecosystems at the same time if we buy that devices from different vendors. Even if they communicate via the same technology or protocol, maybe Bluetooth or Wi-Fi, whatever, they're still not compatible with each other. So this is why you see many systems that becoming more and more popular that do consolidate those protocols. Like the system actually I've been working on for the past 5.5 years does that. We support many, many different protocols and try to unify them and make them available with one user interface for our users. You also would need that to enable at least some kind of automation, like the I click on something and something happens situation thingy you want to have when you have a smart home. So yeah, what the protocol? So the most famous smart home protocols out there at the moment are, I would say, Zigbee, Z-Wave, Bitcoast, which is Homematic and an Ocean as well. Bluetooth is gaining some traction, but they do have a thing in common. So some parts of Zigbee, Z-Wave, Bitcoast, and Ocean, they, at least in Europe, transmit their signals over one frequency, which is in the industrial, scientific, and medical frequency band specification, and is 868 megahertz. Problem is, though, if you go on, like in the US or in Canada, and buy a brand new Z-Wave device or a Zigbee device, it actually doesn't work here in Europe because they do use a different frequency, which is 915 megahertz. Also in Japan, it's something different. So even with the same protocol and products from the same vendor, it depends on where you're going to buy it in the world to make them work together. Of course, there's also Zigbee and Wi-Fi and Bluetooth communicating at 2.4 gigahertz and 5 gigahertz, so very populated frequencies, which also comes with problems. Those protocols, they sometimes, like with Zigbee and Z-Wave, they organize themselves in mesh topologies, which is perfectly fine if you want to have a system with a wide range, because you can have 2 or 3 hops, devices, that then redistribute the signal and basically build this whole mesh network. Problem is, though, we've seen that in our labs, for example, with Z-Wave, if one of that devices in a large mesh network breaks down, it can take up 8 to 10 minutes for that mesh network to rebuild itself. And during that time, your devices are not working at all or not being responsive to your commands, which, if you have things like smoke detectors, etc., can be a bit of a problem. Also, they have different discovery mechanisms, name it UPnP, Bonjour, or MDNS as it's called. Basically, every vendor that has Zigbee or Bitcoast or Z-Wave device implements its own discovery mechanism in a network. It's painful. It is. Implementing that shit is painful. So, simple demo scenario. Basically, all the IoT I was able to fit in my hand luggage when I flew in here. I do have a little demo. Let's just mirror displays. That will make it, no, don't want to open Chrome. Displays. And here we go, perfect. So yeah, I have an ocean-powered switch with me, a light switch. Like usually you mount that on your wall. The interesting thing about this one here, it doesn't have a battery. All the power it needs to transmit the signal is generated via the click. So my kinetic energy actually powers the processor and the sending module in it. It's also extremely noisy. You hear that? That's perfect. I have 2 of them in my living room, and it's horror. It's pure horror. Who invents such things? Okay, and I also have, let's see if that somehow tricky camera business works. Well, here we go, somehow. An Arduino with me with an LED. So basically, all I want to do now is flip that LED. Oh yeah, maybe I should start that server first. And okay, it connected here. Hopefully it connected there as well. And I should bring photo booth back to attention. Okay. So I flip the switch and the light turns on and off. Very, very simple scenario. There in the background you see all the data I'm basically generating while pushing this button. It's, yeah. The interesting thing here is, if I push that button, it sends first a push and then a release command, same with the others. It's very simple. But here, super simple scenario, hand luggage friendly IoT. But yeah, we'll get to how that's done in a minute if I'm stop mirroring my displays again. Okay, so we've done the demo. The code behind looks a bit like this. Is super simplified, no security at all. This is basically the part that lights the LED. You could exchange that with your UBOBs at home and the API there, etc. The Arduino was just very friendly to, well, pass airport security. So what we do here is basically we create a server. I'm using HTTP here. Well, people use MQTT or whatever for that. And every time a request comes in, we just simply toggle that LED and send a request that everything went OK. No rocket science. So we connect to the Arduino and toggle that LED. Everything's fine. On the other side, this is basically the server that reacts on the pushes to the light switch. It connects to a small USB module I have here. Wow. I should not plug that in again. So this is a small USB module, which is a radio transmitter for the Bitcoin protocol. And every time a light switch with that ID comes in with that or this command, which actually stands for the buttons, this one is registered as 30, this one is 10, it transmits or sends out an HTTP request to the server you've just seen and toggles that LED. Very simple binary switch, I'd say. Well, that was the picture that we started with. Light switch, turning on and off an LED. This is the thing we actually ended up with. We now have 4 to 6 computers, depending on if you classify that one as a computer, which is it is technically a computer. And yeah, so we flip the switch. The radio transmitter actually catches the signal. Then we have one server which sends a signal to another server, which then transmits it to the Arduino USB bus and the adapter I have here. And finally, actually, the hardware reacts and switches the light. It's a bit more complex than what we had before. This easy scheme basically repeats in your intranet or in the internet for all the connected devices, or most connected devices. You can have that n times, and you basically mirror that on the other side. You have a device that talks to a gateway, that talks to the internet or your intranet, and on the other side you have another gateway, mostly, that reacts on actions there and transmits data to the device. Thing is, though, it's very complex, but this is not smart. This is not smart home. I mean, this is not even automated. The thing is, we actually reinvented a light switch in the most complicated way. It's nothing more than a simple light switch. And we use 4 to 6 computers and a lot of software to glue that all together. So we sure need light switches, but from a system we pay 500 euros, we kind of expect it to be a bit more than a super complicated glorified light switch. So a typical automated security scenario today looks like this. We have our geofences set up, and if we're leaving the home, the light goes off. If we're coming home, light goes on. That is a scenario that Philips, with their reuse system, has been working for years now. Well, it's still a bit tricky if you live in a household with more than one person. Doable, manageable. But behind all of that, behind all of the automation, may be geofences or may be just reacting on a click on a light switch. There is something in the back that that people call rule engine, the thing that actually connects the dots and make the various devices or APIs work together. So this is an example from the very popular Eclipse smart home system. It's an open source system our solution is based on. And the thing is, this is the geofence trigger. It's a simple binary thing. Hey, if I'm away, turn all the lights off. That is actually all that this blob of JSON is saying. If I'm not home, turn off the lights. And this is also just a fragment of the configuration for such a simple rule. If things get more complicated, more people in the home, maybe I just don't want to turn on the lights if we have a sunny day outside, only at night or in the dawn, etc. This one will get more complicated. And I think it's quite easy to go from there as developers from the perspective of technical people to this UI. Because we just transfer the problem one-to-one to the user, the complexity, highly technical. But the average user is scared of that complexity. We've seen that in all of our user feedback questionnaires we've taken, all the research we've done. The thing is, we need to make interaction with the system more, natural. And one thing, every time I go to that part, I feel very old because I'm going to say, one thing that teenagers these days really do a lot is texting with their WhatsApp and messengers and etc. No, but the thing is, for many of that generation, for many people of that generation, interacting with chatbots, for example, is a very, very natural way of communicating with persons, with systems. It's actually very simple. If you can send a command to your home, turn all lights off when I leave the house, and that converts it into a rule, it's a way simpler UI than this one. If you just have a sentence, a natural language that you can just spit out. I mean, it doesn't need to be a text thingy you see with Alexa and Google Home and whatever, that natural language is a trend, which kind of like then leads us to the smart home. There's a lot of buzzwordy fuss about AI, artificial intelligence, and whatever you call it. I personally do like the term Microsoft coined, which is cognitive services. It's really interesting, well, term for their artificial intelligence services, which is what makes interaction with texts like this possible. Like, this is just a screenshot. You can try that on a Microsoft page. Type a command and control the lights, and it basically gives you all the key entities with weights and indexes from that system. So it is, if we reach the natural connection with the user, it's actually, we're humanizing the computer, and we're making it less scary for people to interact with. For many people in the technology sector, maybe even more scary, but the average user is less scared. We've seen that in our tests and in our trials. Even, so if you even go beyond the voice and the text alone, if you make it even more natural, because if you're in your living room, you never say, hey, or, well, you probably do if you have Alexa, but if you were talking to another person, you would never say, hey, Alexa, can you please turn on the ceiling light, and can you please turn on the light at the sofa? What you would actually do if you were to describe this to a person next to you or the other side of the room, you would do something like this with gestures. Could you please turn on that light and that light, or those lights? This is the thing that makes the interaction natural, human-like. So I set myself a task. So this is part of my job, researching, doing prototypes, etc. I set myself a task. I will take the most uncomputery thingy, the most human thing I can find, and we'll try to, well, do computerized interaction with it. And as Star Trek Next Generation and Data told me, the most human thing computers dream of are emotions. And so I set to a task, myself a task, that a computer can understand my mood. And based on that mood, it can set up a scene at home. Which has, you might think, oh, that's nonsense. There are actual, well, scientific explanations and medical reasons for this. People who suffer from depression, there are studies out there that if the light has a certain temperature, if there is a certain background noise, etc., present, people are less likely to, well, slip into higher depressive periods. So even for that, you might think nonsense example, there is a scientific explanation, not explanation, there is an actual use for it. So yeah, I started off with measuring what determines my mood. So if I sleep less than 4 hours, oh shit, I'm in a bad mood. More than 8, hey, all good. If I have this automated scale at home, or this connected scale, so if my weight goes up, bad mood. If it goes down, well, perfect. And, well, the thing is, I live in Köln, in Cologne. If I'm home with my family, I'm usually in a better mood than at the offices in Darmstadt, which are 200 kilometers away, and I sometimes have to go there. And, well, video happiness, we're getting to that. Also, yeah, I have a bad habit of smoking, and if I go out on the balcony and have more than 4 cigarettes before it's even noon, basically I'm not in the best mood. So I have sensors at home and connected things and gathered all the data for quite some time. This is basically 30 days, 1 month of data I gathered. This is a tiny, tiny node tool, which is really not sophisticated artificial intelligence, more like even not so sophisticated statistics, but it does do the job. So I have the sleep measuring from my jawbone wristband where I can access the APIs. I have my weight from the whiffing scale. I have my location from my phone. And cigarettes before noon, I have that from actual device tracking with a camera or with actual, well, video recognition services from the camera at my balcony. And the video happiness, oh, that's super. So this is like, I use a camera on my desk to measure my happiness, which is also one of the Microsoft services. So yeah, this is me desperately trying to look happy. Well, if you really try to look happy, you end up not doing so. Even if you really try to look sad, you end up like, I don't know, if you've just been out of bed, maybe. Maybe that's even true because I was out of bed when that picture was taken. So yeah, aside from all that data, I've asked myself, okay, every day, so I wrote a little app, and that asked myself, what was your mood today at the end of the day, during the first 30 days? And then I manually entered my mood, my feeling into that app, and after the first month, it had enough data. Well, you can never have enough data with all that statistic stuff, but it had enough data to predict my emotion from the sensor data that has been taken. So this is just running that node script that we've seen. And in the end, it said, hey, predicted emotion today, happy. Sebastian, I've checked everything. You're happy today. Well, I am quite, because I'm here, standing in front of you. And you should really check out this module. It's called Fuzzy. It's really not sophisticated, but has a very easy API. And one wonderful example, it contains a list of mushrooms. 800 mushrooms and all the key characteristics, and if they're edible or not. And then there is a list of 100 mushrooms with the same characteristics, like is it red or has it, like, is it huge or not? But those are not marked as edible or not. And the system actually matches or can tell if a mushroom can be eaten or is potentially poisonous. I wouldn't trust my life on it, but that example is very good and very well working. So yeah, with smart computations like this, native language interpretation, all the recognition, the less invasive concepts, I think this will be the way that the smart home will get to the next level. This functionality will actually then enable people to interact with the hardware and interact with the hardware without even recognizing that they're interacting with that hardware and the software, of course. It really blends into the background. This is the thing we're going to achieve in the future, but we're not there yet. It's simply a fact. Let's just leave that complicated light bulb, light switch scenario where it belongs, enable the users. And I know this has been maybe less technical than you expected. If you like a deep dive into that topic in particular, especially protocol madness and open source systems, I wrote a piece 1.5 years ago for the IX developer, in German, unfortunately, sorry. But there are also other talks for fun and profit from me in the past years. The links are included in the slides, that tackle, again, like user interfaces or hardcore protocol, well, reverse engineering, or fun projects. I would never say art projects because I'm not an artist, but some interesting hardware thingies. So if you want to dive deeper into those topics, the videos are available, and the links are in the slides, and I'm going to tweet them after the talk. So at the end, there's just one thing I can really, well, tell you. I need to tell you, please, whatever you're working on, if it has nothing to do with IoT, it probably has to do with users. Don't be stupid. Don't be Seattle. Don't build 9-meter-high walls in front of your customers. Try to enable them, not to hinder them to do things. And with that, I'd say thank you very much for listening.